of our universe. The coldest spot isn't a distant star, but right here, inside this laboratory. To bend the very rules of reality, we must venture into a world of absolute stillness, far below the temperatures of deep space. Watch as the temperature plunges, moving past the freezing void of the cosmos toward the ultimate silence of the 0 point. At 10 millikelvin, heat effectively disappears, allowing the delicate dance of quantum particles to begin without any interference from the outside. We dive deep into the heart of the dilution refrigerator, where layers of gold and steel protect the most fragile secrets of physics. This is the fortress of cold, a place where time and energy behave differently, paving the way for a computational revolution. Imagine this machine as a majestic golden wedding cake, where each descending tier serves a vital purpose in removing thermal energy. Every plate is meticulously crafted to isolate the processor from the slightest vibrations, creating a sanctuary for the fragile quantum bits. Within these veins, a mixture of rare helium isotopes flows, stripping away the last remnants of heat through a complex phase exchange. This liquid coolant is the lifeblood of the system, circulating tirelessly to maintain an environment colder than anything found in nature. We descend further down the spine of the machine, moving from the warmth of our world into the cryogenic heart of the future. With every inch, the environment becomes quieter, more stable, and infinitely more focused on the singular goal of quantum coherence. At the very bottom lies the payload, the quantum processing unit, waiting in the most silent corner of the known universe. Here, in this extreme isolation, the laws of classical physics finally fade away, making room for the magic of the quantum realm. Zooming into the silicon heart, we see superconducting circuits that glow with a strange, ethereal light, ready to process impossible data. These microscopic bridges, known as Josephson junctions, act as the gateways for information, allowing energy to flow without any resistance. Think of this processor not as a machine, but as a grand orchestra where atoms are the musicians playing the music of reality. In this atomic symphony, every particle contributes to a harmony of data, vibrating in a synchronized rhythm that transcends ordinary logic. Unlike a normal computer, these qubits can exist in a state of superposition, being both 0 and 1 at the same time. This allows the computer to explore every possible solution simultaneously, turning a linear search into an instantaneous discovery of the truth. And a single qubit can hold a multitude of possibilities, shimmering like a sphere of light that contains an entire world of potential. When thousands of these spheres interact, they create a complex web of calculation that would take classical computers billions of years. The heart of the machine hums with the power of the infinitesimal, orchestrating a logic that defines the very fabric of our universe. But the real magic happens through entanglement, a mysterious link that binds two separate qubits together across the vast digital landscape. This neon thread of light represents a connection so deep that the two particles behave as if they are a single entity. When we change the state of one qubit, its partner reacts instantly, regardless of the physical distance that lies between them. This spooky action at a distance allows the computer to synchronize its entire memory instantly, creating a unified field of processing. Slowly, a massive network of these connections emerges, forming a glowing brain of light that thinks in ways we are only beginning to understand. This is the key to unparalleled power, a web of information that is more than the sum of its individual parts. Information flashes through this lattice at impossible speeds, solving problems once considered completely unreachable by human technology. We are witnessing the birth of a new kind of intelligence, one that is woven directly into the fundamental laws of nature. The entangled architecture stands as a testament to our mastery over the invisible, a bridge between the macroscopic and the quantum. Yet, this beauty is fragile. Even the tiniest stray photon or a hint of warmth can shatter the delicate quantum state. When noise enters the system, the symphony turns to chaos, and the precious information dissolves into a sea of useless static. This loss of coherence is the greatest challenge, a constant battle to keep the quantum world from collapsing into ordinary matter. To fight back, we deploy advanced error correction algorithms that act like a digital shield, protecting the integrity of our calculations. These invisible grids scan for errors and restore the harmony, ensuring that the quantum logic remains pure and focused. We also use ion traps, firing atomic particles into precise electromagnetic cages to keep them perfectly still and shielded from heat. Every atom is a prisoner of our design, held in a vacuum so perfect that it rivals the emptiness between the stars. It is an endless war against the chaos of the universe, a struggle to maintain the perfect silence required for quantum thought. From this cold heart, we will unlock the secrets of new medicines, designing life-saving drugs by simulating the very building blocks of biology. We will discover materials that conduct electricity with no loss, and solve the mysteries of space-time through pure quantum simulation. As we step back from the golden machine, we realize we are not just building a computer, but a new window into reality. This is the dawn of the quantum age, where the impossible becomes routine and the mysteries of the universe are finally solved. Welcome to the future of computing. Welcome to a reality redefined by the coldest spot in the cosmos. The era is here.